Today in this video lecture, we will see chapter 5 principal stresses and strains. In this introduction topic, we will see principal plane, principal stress, major and minor principal stresses and principal planes, and resultant stress and angle of obliquity. So, first the introduction. First bullet point is we have studied the effect of simple stresses which were either normal, tensile or compressive or tangential acting on a particular plane only. In our previous lectures, we had seen tensile or compressive stresses and shear stresses. So see, consider this is beam and this beam carry uniformly distributed load W kilonewton per meter, and due to this load, this beam bends. Due to this external loading, there are internal stresses develop in this beam, and these internal stresses are either normal or shear. Normal stresses are tensile or compressive. Tensile are like bottom tensile denoted as capital D and top compressive denoted as capital C. And consider section XX of this beam. It is square beam, and this square section also carries shear stress, also develops shear stress. And it is tangential to that square cross section. So these are simple stresses: compressive, tensile and shear stresses. Shear stress denoted as tau. So these stresses we had studied. Second bullet point is most of the cases in actual members more complex condition of stresses are developed. Third, in this chapter we study the analytical and graphical method to find the stresses acting on an inclined plane of the member subjected combined stresses. So this third bullet point, that means consider one rectangular body. This body carries axial load Px. Stresses acting on an inclined plane of the member subjected to combined stresses. Inclined plane, that means this, and stresses acting on that inclined plane is this is Px. Consider, so here normal stress acts sigma n, and here tangential stress sigma t, and here also normal stress and tangential stress. So these are stresses acting on inclined plane, and this stress is sigma n normal stress, sigma t tangential stress. We will calculate in our next derivation. The plane on which normal stress or shear stress reaches their maximum intensity have particular significant effect on the materials. Second is principal plane. A plane on which only normal stresses acts and no shear stress is called as principal plane. For that, principal plane is the plane on which only normal stresses act and no shear stress is called as principal plane. Let us consider this rectangular body. A, B, C, D, and this body carries normal stresses sigma x, sigma x. So the plane AB, this plane AB, and this plane BC, this CD and this AD, as shown in this figure, carries only normal stresses and no shear stress. This sigma x is normal stresses. Here, see this red color stress is shear stress, and this body not carries this red color stresses, shear stresses. So that's why this is only carries normal stress. And this plane AB plane, DC plane are principal plane. Principal stress, next 5.1.2 bullet point is principal stress. The magnitude of normal stress acting on the principal plane is called as principal stress. So here magnitude is nothing but the magnitude of this normal stress. That means sigma x is equal to like 20 Newton per mm square. Unit of stress is Newton per mm square. Stress is load upon area. Third bullet point is 5.1.3 major principal stress. It is the maximum value of normal stress acting on principal plane. It is maximum intensity of direct stress. This maximum value of normal stress acting on principal plane, and it is maximum intensity of direct stress. Maximum value, that means like this is 200 or 500 like this. Minor principal stress, it is the minimum value of normal stress. See this value word. Value, that means this 200 Newton per mm square, and it is minimum intensity of direct stress. Five point 1.5 bullet point is major principal plane. A plane which carries major principal stress is called as major principal plane. So this AB plane and DC plane, AB plane or DC plane, carries major principal stress. That means this it carries like 500 Newton per mm square principal stress like this. And minor principal stress, that means a plane which carries minor principal stress. That means this AB or DC plane carries only 5 Newton per mm square stress. So this is principal plane, a plane on which only normal stresses act and no shear stress is called as principal plane. Principal stress is the magnitude of normal stress acting on the principal plane is called as principal stress. Major principal stress is it is the maximum value of normal stress acting on the principal plane. Difference between principal stress and major principal stress is only this major word, only major maximum value considered in this major principal stress, and minor principal stress in this minor value considered of normal stress. Major principal plane, a plane which carries major principal stress is called as major principal plane, and minor principal plane, that means a plane which carries minor principal strain. See, common between these is the stress. All are the function of stress, only major and minor, these are differences. Next is resultant stress. The resultant of the normal stress and the tangential stress is called as resultant stress. Consider section XX and section XX acting normal stress sigma n and tangential stress sigma t. So, resultant of this normal stress and tangential stress is this. Sigma r. Here, sigma n is normal stress. Sigma t is tangential stress. And sigma r is resultant stress. So, this sigma r is equal to, these are vectors, sigma n, sigma r, sigma t, all are vectors. These vectors, like this sigma n are like this sigma r is like this. This is sigma r, and this sigma t, take here. This is 90 degree. So this sigma r is hypotenuse. Sigma r is equal to under root of sigma t square plus sigma n square. So this is the equation for this resultant stress. And this angle between sigma n and sigma r is phi, and this angle is nothing but angle of obliquity. This angle of obliquity, the angle made by the resultant stress with the normal stress, is called angle of obliquity. Sigma n, sigma t, sigma r. between normal stress and tangential. Normal stress, and here this is resultant. This is sigma r. See here. This is tangential. And this angle of obliquity is denoted by phi. So tan phi is equal to opposite side upon adjacent side, sigma t upon sigma n. So stresses on a oblique section of a body. So following are various cases for determination of stresses on oblique section of a body, a member subjected to axial stress. Member subjected to axial stress, that means this is rectangular body ABCD. This P load acts on this body. So this is member subjected to axial stresses. Second is a member subjected to normal stresses in two mutually perpendicular directions. Here sigma x stresses on AB plane. Here also sigma x stresses on DC plane. Two mutually perpendicular direction means this AD plane directions also. This is also sigma y. So this is second bullet point. Third is a member subjected to shear stress. So only shear stresses acting on this plane AB, BC, CD. On plane AD, shear acting. On plane BC, on plane DC, and on plane AB also. And fourth is member subjected to normal stresses in two mutually perpendicular directions, that is this case, and accompanied by simple shear stress, that means combine these 2 and 3 case. These are all cases for determination of stresses on oblique section of a body. That means here this normal stress and tensile stress is developed. So these stresses we develop by using all that cases. For all that cases. Sigma x and shear tau. So this is introduction of principal stresses and strains chapter. Thank you very much.